and the function is given to us. So obviously, as you see, the interval 1 to 5 is broken at 3. So this will be a sum of two integrals from 1 to 3 and from 3 to 5, because we don't have the same function between 1 and 5. So therefore, what I have between 1 and 3 is the function 2x plus 1 dx, and what the function I have between 3 and 5 is x minus 10 dx. And now at this point, I just have to evaluate. Is this step clear? Yes? Okay, so let's evaluate. So now we have 2x squared over 2 plus x from 1 to 3, and then x squared over 2 minus 10x from 3 to 5. Is this okay? Remember this weekend to redo all tests with solutions several times. Okay, so I plug in 3. I get 9 plus 3 minus, when I plug in 1, I get 1 plus 1, which is 2, plus I plug in 5, 25 halves minus 50, minus, careful parentheses, 9 halves minus 30. Now, for these integrals, I don't want you to spend too much time on the arithmetic. So if you write this step, and you say, oh, I may have time later to come back and add them up, that's fine. If you stop here, I'm fine too. I'll give full credit. Because I don't want you to, you spend too much time on adding fractions. So I'm assuming you're here, you know how to add fractions. So I'm going to do this. So this is 1, so 10 minus 50 is minus 40, and then plus 25 halves. And this is minus 9 halves and plus 30. So now this is negative 10 plus 25. Actually, 25 minus 9 is 16. And that's 8. So that's negative 2. I also, sitting here, I wrote solutions so that when I get home, I can. First, I'm going to my office to get your tests, and then I'll get home and grade. So if you want to see any of this or do anything with this or any problem, we can go over this also. So, April, is this okay? Okay, good. Anything else? Any other problem or question that you may have? Yes.
So from the test,
From this one?
yes.
Yes?
There was a problem about based off of the change of volume of the cube determine the
Yes.
area.
Yes, let's do that. So we were given, obviously, dV over dt as 10 cubic centimeters per minute, right? It says the volume of a cube is increasing at a rate of this. How fast is the surface area of the cube increasing when the length of the edge is 30, right? Okay, so this is given to us. And the volume of a cube is x cubed, right? So then dV over dt equals 3x squared dx over dt. Is this clear? We all agree with this, right? Okay, so now my focus is the surface area, which is 6x squared. Would you agree? Imagine a die, right? It has 6 faces. So then 6 times x squared, that's the surface area. Agreed? Okay, so then ds over dt will be 12x dx over dt. From here, I will solve for the x over dt to plug it in here. So dx over dt is this over this. So dv over dt, everything divided by 3x squared. And now I have everything and I'm going to put them together. So ds over dt equals 12x times this, dv over dt divided by 3x squared. I can simplify. So what I have is 4 over x, because 3 is gone, there is only one x in the denominator, times dv over dt. So now when x equals 30 centimeters and dv over dt equals 10 centimeters cubed per minute, all I have to do is plug them in. So 4 over 30 times 10, and this is 4/3. Since its area is centimeters squared per minute. Is this okay? Is this okay? Is it clear?
Makes sense.
Questions on this?
So the way the question read, how did we know we had to find the surface area?
Ah.
That's what I was confused. I really
How fast is the surface area
of the cube.
of the cube increasing when? So I had to come up with a function that represents the surface area.
Right.
And since when the volume changes, the surface area changes, as well as the length of the edge changes, right? They are all three functions of time. Is this better? So now since everyone is here, so test 3 is here in this room at 10:30 on Saturday, unless you want to take it in the testing center. Here, 10:30? Okay. I think Brian said testing center at Rundle Mills. April, here in the room. Emily?
Testing center.
Exactly, because you want it on Friday. Chloe?
Can I let you know Thursday?
Yes, but remember I have to send it.
Okay. You can just put it in the testing center. I don't mind taking it or Saturday.
Here?
Yeah. That's fine.
Okay. So 1, 2, 3 in the testing center and 2 here. Okay. Now, if you want it at the Rundle Mills, if it's easier for you, I can send it there, but.
No, that way I can tell my husband I have to come.
Okay. Okay, any questions on this? Okay, anything else?
I'm sorry, I didn't get this right.
Yes, any questions? Is it clear what I just did here?
Yeah, so from what I understood the problem, I got that we had dv over dt, that was the given.
Yes,
We were trying to find ds over dt.
correct.
And I was up to it up until
Finding
6x squared.
dx over dt?
Well, the thing is, I hadn't thought to plug them in like that. Like, yeah, I ended up finding,
So when you write the volume up there, then you see and you differentiate. We differentiate the volume, which is x cubed, you get 3x squared dx over dt, and you can solve this equation for dx over dt, which is here. You just have to put this at the top and divide by 3x squared.
mhm,
And this is what I put in here.
yes.
So it's 12x dx over dt, and I just copied this in here.
And then
we simplify and we plug in the numbers.
Yeah.
So we simplify to this, and now x is 30 and dv over dt is 10. And that's how we get 4/3 centimeters squared per minute. Is that okay?
yes.
Can you move it down just a minute? How did you know your dx/dt was your volume over time divided by 3x squared?
Because when I differentiate this equation, volume and x change at the same time, so they're functions of time. When I differentiate this, I get this. When I differentiate this, I get this.
Okay.
And when I differentiate the surface area, I get this piece, which I don't have. So when I'm solving, like we solve any different implicit differentiation, when I solve for this, I divide both sides by 3x squared.
Oh, okay. Well, that makes a little bit more sense now. I just
So
had
now
a
this
very
P.
difficult time setting it up.
Then this piece is this. So I just replaced it. Is that better?
Yeah. It would be really helpful too if we had very clear steps on how to solve each problem, because I feel like every problem is kind of like maybe can vary, but if there's just generalized steps for each one.
Related rates problems, they are so wide.
Yeah.
And yes, so
Understanding of this.
so the only thing that I can suggest for related rates is read the problem several times, create a function that you need to differentiate implicitly, and then plug in the information. But I can't give a recipe for each and every one of them, because in some situations you may be given a function, you may be not given the function, you may have to create the function, so it depends on the problem. Yes, April?
Can you go over the one that was like with photosynthesis?
Yes.
That one I had a hard time too. It was those two. This one and photosynthesis.
So it's right here. So let's look at the function. But we know what we need to do. What do we need to do with it? I copied all the problems from your book. I didn't invent anything.
Find the derivative?
Yeah, exactly.
I don't know why I had.
So
such a
P
hard
of
time.
I equals 100I over I squared plus I plus 4. It's just a rational function. Now, if you say, well, this I bothers me, let's change it into X, and at the end we can go back to I. I don't, yes?
Oh, no, I'm just saying, I understand what you're saying, because we're used to X.
Right, right. Do you prefer I, or you want to change it to X?
No, let's just leave it like this. And
Okay, so this is basically 100 I over I squared plus I plus 4. So when I differentiate P prime of I have 100. The numerator prime is 1, so this is I squared plus I plus 4 minus I times the denominator prime, which is 2I plus 1 over I squared plus I plus 4 squared. Now up until this point, there should be no problem. Would you agree? Yes. Right? So I put the constant in front like I always do, just to simplify things. Top prime is 1, so times the denominator minus top times the denominator prime, 2I plus 1. So far, so good? Okay, so leave 100 waiting. So this is I squared plus I plus 4 minus 2I squared minus I over I squared plus I plus 4 squared. These two go away, luckily, and I get negative I squared plus 4. So this is 100, negative I squared plus 4 over I squared plus I plus 4 squared. And eventually I have to set it equal to 0. It's a fraction. It will be 0 only if the top is 0. Which means after I move forward, divide by -1, I get I squared equals 4 or I equals plus or minus 2. But I is given in the problem as being greater than or equal to 0. It's the light intensity. So I will say only I equals positive 2. And the measurement unit, thousands of foot candles. So I'm done. However, I have to show that this gives a maximum. So this is I, this is 2, p prime of I, and this is 0. And this is 0 and infinity. All I have to do is plug 0 in here. So please plug in 0 and tell me the sign. Of course, you're not going to plug in this, because this is always positive. So you're only going to plug in the top. What do you get? Right. And now let's say we plug in 10. So when I plug in 10, of course, not in all this. 10 with minus squared with minus in front plus 4 will be
Minus negative.
correct, right? So this is typical for a max. If you want to, you can also determine it. Is that okay, everyone?
Much easier when we do it this way. I made it so much more difficult.
Because you had it off 100 or?
I don't even know. I went back and erased it. I started doing the derivative, and it could have just been the i's and me.
Maddie, is it clear why this is negative with 10? You're not squaring negative I. You're squaring I, and then you multiply by negative 1.
Okay.
It's not, this is not in parentheses.
Okay.
So you have to square first, and then you multiply by negative 1. So whatever, it's minus 100 plus 4. Is that clear, everyone?
So I guess why is it not in parentheses? If it's negative I squared. Like, I mean, any negative number squared is positive, so why is that?
Very good. Okay. Negative 2 squared is not the same with negative 2 squared. Here, by the order of operations, I have to square 2, and I get negative 2, and I get 4. Here, by the order of operations, I have to square 2, and then I multiply by negative 1, and I get negative 4. So now this is, however, the same for power 3. These happen to be the same. Oops. These will be the same. This one is negative 8, and this one is 2 to the third, which is 8 with minus in front. But when the power is even, they're not the same. So when I am evaluating, for example, f of x equals negative x squared for negative 3, I don't write this. That will be incorrect. I have to write this. This is the negative, and then I square negative 3. So negative 3 squared is 9, with minus in front will be negative 9. Okay, next question. Anything else you would like to go back to? So that was what I wrote for you, step by step. And I also determined it. We were not asked to find it, to find the maximum, but I determined it. So it's right here, it's 20. And before I scan it, I should put it in. Okay, so I'm hoping that you had absolutely no difficulties with the first problem. Yes. So the first derivative was this, the second derivative was this, and the sign. Yes? Okay. So that was it. I hope you had no difficulties with number 2. So 2, 3 is nothing, 3, 1 is the absolute and local minimum, and 4, 5 is the absolute max. Okay, then this one. If you need me to show any of this, please do say so. So I hope you didn't have any problem with the marginal cost, and then plugging in 100, and I'd find the exact cost of manufacturing 101. So the exact cost is this. And use marginal cost to estimate, and that's all it is. C prime of 100 times 1. Okay, so this one, the implicit differentiation. Any questions on that? we only had one, just one variable. So this is 6x squared, 2x times y plus x squared times dy over dx and minus 1. So we didn't even have anything to factor out. So
We didn't do the, what is it, the product rule?
yes, it's right here. This is the product rule. So I kept this and this here with minus, and I moved this to the other side. Oops. Right, because I kept this on this side. I kept these three terms and I moved this to the other side. So it becomes negative x squared. Okay, then we talked about this. Now, anything about the integrals? So if you simplify them like this, fine. If you didn't, fine too. I just wanted to see the correct integral, derivative. So I did try to simplify them a little bit, but
I have difficulty simplifying D and F.
in D, I factored out x squared and e to the x squared and e to 2x.
Okay. I know I got the first one.
And then I simplified. If you simplify it or not, that's fine. So this will be the final form. And this is, I didn't do anything else. You can multiply a little bit. You can simplify by factoring an x. So you get x minus 2 and you simplify with an x minus 2. So I stopped here. I may go back and make some adjustments. Okay. Okay, what do you want to continue with? Any type of problem that you would like to continue with? Anything?
Did we already do the packet for test 3?
Oh, I think we did, but we can go back to it.
We're still missing. I mean, we skipped them because we.
Oh, yes, let's go back. I don't remember, you keep me straight and tell me what, we did find the average, I remember that. I remember doing this problem. But I don't remember doing these. Maybe not all of them. In 5.
We did everything up until 6.
Oh, did we do 6?
No.
Okay, that's the one okay, we didn't do 6. Okay, let's do it. So we're given a demand function of x minus 8 squared, and we are given a supply function, which is x squared. Very good. So we are asked, first of all, to find the equilibrium point. How do I find the equilibrium point? Very good. So x minus 8 squared equals x squared. You have several ways here, but let's go with Emily's method. I would have put x squared to the other side and factored out using the difference of squares. So that's fine. But then x squared minus 16x plus 64 minus x squared equals 0. So this is negative 16x equals negative 64, so x equals 4. So from the break even, I'm sorry, this is not the break even. The equilibrium point is 4 comma something. So it's not a point if I only have x. So it's 4 comma what?
16.
Exactly. Because you plug it in either one, doesn't matter. So 4 squared is 16, indeed. So 4 comma 16. So now remember two formulas. The consumer surplus is the area from 0 to 4 from x minus 8 squared minus the area of this rectangle, 4 times 16. So the producer surplus is this area, 4 times 16, but minus the integral from 0 to 4 from the other function, from the supply function, dx. So these are the two formulas we need to remember. We kind of prove them together. Okay, so let's do that. So the first one, the consumer surplus, the integral from 0 to 4, x squared minus 16x plus 64 dx. And this will give us x cubed over 3. X cubed over 3 minus 16 x squared over 2 plus 64x from 0 to 4. Oops, oops, oops. Minus 64, please. Don't let me forget. And minus 64 equals, I plug in 4. 64 over 3 minus, when I plug in 4, so I'm going to simplify. So 8 times 32, no, I'm sorry, 8 times 16 plus 64 times 4 and minus 64. Okay, let's see what we get. So 64 divided by 3 minus 128. Here, this is what I like to do. I factor out 64, so 64 times 3. So 64 over 3 minus 128, but plus 192, I think. So this is 64 over 3 and plus 64. Was it minus? No, that's fine. So it's 64 times 4/3. I'm checking my numbers. 8 times 16 plus 64 times 4 minus 64. So 64. I think this is okay. 4 minus 1 is 3, so 64 times 3. 128, 192, 4. Yes. Yes. So this is 6 over 3. So that's in dollars. I should take at least the integers out. 85 and 1/3 and 2/3. Dollars. Okay, let's see what we get with the producer surplus. So this is 64 minus the integral from 0 to 4 from x squared dx. Emily, is that what you got?
Yes.
Perfect, thank you. So 64 minus x cubed over 3 from 0 to 4. So now this is 64 minus 64 over 3. I'll do the same thing, factor out 64. So it's 64 times 2/3. 128 over 3. So I should take at least the integers out. So this is 42 and 2/3. So we are getting from them this extra without paying for it, and they are getting away with 42 and 2/3.
Since it's dollars, should we put it as a decimal?
You're right, it could be,
Okay.
but since it's the exact, I would just keep it as is.
Okay.
Okay, so that was, okay. I think we did problem 7. Show that e to 11x is a solution of the differential equation. Right?
Okay.
And I think we did number 8. Both of them, A and B. Yes? And I think we did number 10.
We did 10, we did not do
9. Let's do 9. So here's 9. We have V of L, P, R, little r, and V. So it's P over 4 LV, R squared minus R squared. All they want us to do is find V of the given numbers. That's all you do.
I'm sorry, but this is-
So V of 1, 100, 0.0075, comma, 0.0025, comma, 0.05 is P. P is the second one, so that's 100. 4. L is the first one, 1. V is the last one, 0.05. Now, R is the third one, 0.0075 squared minus 0.0025 squared. So I will put this, of course, in the calculator. Don't even attempt anything. So, but be careful, 100 multiplied by, in parentheses, 0.0075 squared minus 0.0025 squared, close the parenthesis, and only now divide by, and in parentheses, 4 multiplied by 0.05. Close the parenthesis and press enter. 0.025. Do not divide and then multiply because the calculator will do something else. Be very careful. So multiply everything at the top and then divide by this in parentheses. This must be in parentheses. Okay, we did number 10. I don't think we did the 11 and 12. Am I correct?
Correct.
Okay, very good. So let's start with which one? Very good. So we are given a function of two variables, 7xy squared, 5xy minus 2y. And they want us to find everything, fx, fy, fxx, fyy, and fxy or yx. It's going to be the same. Ready? So can anyone give us fx?
14x.
So, hold on. So we are differentiating this with respect to x. So the answer must be 7y squared. We're differentiating this with respect to x. So it's positive 5y. Would you agree? Okay, let's also, since we have this, let's find fxx. What is fxx?
14y.
We are differentiating this expression with respect to x.
All of those are constants, so 0.
Excellent. Let's find fy. Yes, it is 14xy plus, indeed, minus. That's it. Let's find fyy. We're differentiating this expression with respect to y only.
14x.
Good, excellent. So we're done with fx, with fy, with fxx, and fyy. Or we only need now fxy and fyx. So maybe I should put them here on the side. So I want to differentiate this with respect to y. Excellent. I want to differentiate this with respect to x. The answer must be the same. So fyx. Let's differentiate this with respect to x.
14y plus x. Plus y is right.
That's it. They must be the same. When you get to fxy and fyx, they will be the same. Good. Any questions here? Is this okay? Okay, so let's look at 12. Find the relative max or min values of, so this is the D test. fxy, x squared plus y squared minus 4x plus 2y minus 5. So let's summarize the D test. We have to find fx and fy. Set them both equal to each other. Find the point. And then determine fxx at the point, fyy at the point, and fxy at the point. And then create the t-test. So, first step. We have to find fx. And we have to find fy. And then we'll create a system by setting them equal to 0, not to each other. Ready? So fx,
2x minus 4.
fy.
2y plus 2.
Excellent. Now we create a system. 2x minus 4 equals 0, and 2y plus 2 equals 0. Obviously, x is and y is. And this is our point. This is the discussion, meaning if it's a saddle point, if the test is inconclusive, or it has a max min. If it's 0, if D is 0, but later, not now. Okay, so what is the point? 2, -1. Good. In step 2, we have to find fxx, fxy, and fyy. And we know that fxy is the same with fyx. And then we will have to evaluate these three at 2, -1. Can anyone give us fxx? 2, and there is nothing to evaluate. There is nothing I can plug in. Can anyone give us fyy? 2. Same thing, there is nothing I can plug in. If I have 2x, yeah, I'll plug in 2. If I have 2y, I'll plug in -1. Okay, so now we have to differentiate fx with respect to y. 0. So in step 3, since there is nothing to evaluate, I cannot plug in 2, -1 in any of them. These are fixed now. I have D, which is fxx at positive 2, -1 times fyy at 2, -1 minus fxy at 2, -1, but this must be squared. So we have 3 possibilities. For D to be 0, to be positive or negative. So how much is fxx? 2. How much is fyy?
2.
And how much is xy?
0.
Yes. So 0 squared, so this must be 4. So this is what we want to see, because 0 or negative will not give us anything. So we got that D is a positive number, but now we have to look at fxx. If fxx is positive at 2, -1, that point, 2, -1 is a minimum. If fxx at 2, -1 is negative, then that point, 2, -1 is a maximum. But fxx is a positive number. So then I don't have to plug in anything because there is no room to plug in anything. So then D is positive. I meant to write positive. D is 4, which is positive. And fxx at 2, -1 is also positive. What do we conclude about 2, -1? And we should determine it. Yes, it's a relative min, not absolute, relative. So now we can determine f of 2, -1, and this will be the relative min. So I go back to the function. 2 squared is 4 plus -1 squared is 1 minus 4 times 2 is 8 plus 2 times -1 and minus 5. I just plugged in the original function. So this is 5 with -5, and this is -8 with -2, which is -10. So this function has a relative minimum at 2, -1 and the actual minimum is -10. There are functions that have both max and min, of course at different points. Okay, so here's another. Would you like to work on this for a minute? It's the same type of problem. Yes, exactly the same. Would you like to work on it for a couple of minutes?